Okay, so in this video we're going to be covering something in Python called list comprehension. This is really useful for when you have to quickly modify, change, do something with a list and you want to just do it in one line without having to iterate through it using a for loop. List comprehensions can come in very useful before you pass a list into some other function and you want to change something in there or reorder it, take something out. So it's a really powerful tool. It's a very succinct way of writing code, and it's something you need to really master to advance in your Python skills. So let's take a look at list comprehension. Okay, so let's look at iteration and list comprehension. And before we go into greater detail, let's look back at for loops and how they work. If we're going to look at the for loop, well, what we need is something to iterate over. In its simplest form, this can be a list. And as you can see on the screen here, I've got a list of cars, some of my favorite brands there, some new ones, the Grenadier, not yet come out. Anyway, going into detail, we've got the for loop, okay? And how does the for loop work? Well, there's a number of parts to the for loop. The first one is you need that variable, which holds each element of the container, sequence or generator. In this case, that's cars, which is a container, sequence or generator that contains or yields the elements that we're going to loop over. In this case, above that list is cars. We are going to iterate over each and every one of these items in the list, being a name of a car. Basically, what can be contained here, what can be here is anything that uses the iterator protocol that then can be used in a for loop. Now, what's this for loop going to do? It's probably the simplest you could find. All it's going to do is print out every single X as it goes through the list of cars in this list. Okay, list comprehension. Now, how does that work? Well, how do we get this for loop into one succinct line? So what we're going to do here is we're going to define a new list, which is cars, and this is going to print X for X in cars. Now, what's going to happen here is it's not actually going to return a list at all of cars. It's going to return a load of nuns, which I want you to take in to account here. But what it will do is it will print out the X's. So every single one of these will be printed out as it runs through and iterates over the elements in cars. And what I've done in this is, you can see I've got the color coded, so you can see how each component part of this for loop is represented in a list comprehension. So the variable goes here. What you're going to do with that variable goes at the front, so it's a little bit backwards in that sense, and then the container, sequence or generator, in this case a list, goes at the end. So let's just run over iteration first in PyNotebook that I've got up running. So let's get our list of cars. In here we had a Ford, followed by a Tesla, a Volvo, don't forget the brackets, otherwise it won't be strings, then a Rivian, and a Grenadier. Who knows if that's going to be a success or not. And I've forgotten the equal signs here, so we can commit that. There we go, that works for us. So how would we iterate over that and just print something out? Well, like I showed in the PowerPoint that I just had up, if we have to do a for loop. So for X in cars, print X, and that'll just print out our 4 car names as strings in the order that we inputted them. How will we do this with a list comprehension? So we would write cars equals print X for X in cars. Now I want to point something out here. When you do list comprehension, it creates a new list for you. It assigns it to the variable that you pass at the front. So this will create a new variable of cars, but all we're doing in this situation is to mimic this simplistic for loop is printing X for X in cars. So what we should get is 5 nuns because we're not outputting X, we're printing X, we're doing something, we're printing it, we're just doing something with it and then discarding it. So that's an important thing to recognize. So what we should see here is exactly the same. Let's get rid of this for loop. Let's just comment it out so you can still see it. Exactly the same. Now, if I then, let's display what cars is, and now in Jupyter Notebooks, if you want to see what something is, you just leave it as the last line item in the window, and it will show you. You can see that I've got an array of 5 of nuns. So that's what I'm talking about here. We're not doing anything. It's passing nuns in because nothing's going in there. But if we put X plus, think about it. Let's put a bit of string beforehand. The plus X. So this should then say the Ford, the Tesla, the Volvo, the Rivian, the Grenadier. There we go. So we've actually done something with it there. Whereas the print X was merely just printing it and then just we were getting none. So that's always worth remembering if you're kind of doing an if else, which we'll come on to later, that you might end up getting nuns in there unless you put an else into the statement. Okay. Okay, so one of the things we can do with the list comprehension is we can use it to add some conditional statements in there. So use it to sort of filter things out of certain lists, which is helpful if you want to exclude items from a list before you pass it into another function, or maybe put it as a list going into something that you're doing on a data frame with pandas or something like that. So what we use here is we add a condition in, and as you can see here, we've got this conditional test of the for loop if A is in X. So if A is in the car name, print the car name. Now, how do we put this into a list comprehension? Well, it's just added on at the end. And one thing I want to note is that it's not like when you're declaring a list and you have commas in there. It's all just one long set of characters. There's no special characters, no symbols in there at all. So it will pick up on this if here. And what we'll see is only those car names which have got A's in them, so Tesla, Rivian, and Grenadier, will be printed. Okay, well, let's take our list comprehensions that little bit further. We've got our list of cars that we like, and let's just look at how we do a for loop with an if statement in it written out. So I'm going to change it a little bit. I'm going to do for car in cars. I quite like doing it this way because it helps me understand what's going on. So the car is in a list of cars. As long as you remember to keep your S's in the right places when you're using plurals and singulars, it works quite well. So for car in cars, if, what do we say in our example? If A in car print, so I have to spell it right, car. Got that wrong, huh? Needs to be a character. There we go. Tesla, Rivian, and Grenadier. So we've got the A in those words, and that's where we got to. Now, let's just comment those out and move on to the string concatenation. So we're commenting them out just by putting the pound sign there or the hash, depending where you're from, and for reference, so you can still see it in there. So how we do it with the list comprehension, right? Okay, so we're going to declare a new list, but we're just going to redeclare cars. Cars equals, right, print car for car in cars, for car in cars. So this is like the start of our for loop there for car in cars, and then if A in car. There's no, it's just one continuous line, there's no commas or anything like that. If you made the same mistake, if A in car. And you get the same result. And just like before, to show you what's going on, that's from before, we're getting none, none, none. So we're not doing anything with the car itself. So if we want to return something, we would do whatever we want to do to that with in the first mention of the element that we're iterating with over the object, the iterable. So let's do what we did before. The car for car in cars, if A in car. The Tesla, the Rivian, the Grenadier. So that's how that works. Quite straightforward. So just looking back on it, you've got for car in cars, that's be for car in cars, and then the if statement comes after it. So pretty straightforward at this stage, but just that little bit more detail. Okay, so we're going to take this a little bit further and introduce the else statement into what we've been working with here. So we've got our for loop as we've been using for x in cars, if A in x print x. Now we've got the else print A plus x. Now this is where things have changed up a bit. Down here you can see that we've got the else print A plus x for x in cars. The for x in cars has moved to the end because it's a if else statement here. So that's an important thing to bear in mind. Let's go over to Jupyter Notebooks and see how this works. Okay, let's look at our list comprehension now with if else, and it changes it up a bit more. So just to go back and look and see how this works with our standard for loop. So for car in cars, and let's say if A in car, so if the letter character A is in the car, we're going to just print car. Else, get our indentation right, we're going to print A space car. So there we go. So we've got an A in if an A in the car, we're just going to print the car. So Tesla, Rivian, Grenadier, they've all got A's in them. We're just getting that. Otherwise, it's going to do A, print A, car there. So that's how that works. Now, in our list comprehensions, how do we have it set up? So cars equals print X. So that's print car. We're talking about cars here. Now we moved on to the example. Print car if A in car. Now this is a bit different. Else print A plus car for car in cars. So primarily this is what's going to happen if A is in car. Otherwise this is going to happen for car in cars. So the for car in cars happens at the end. So we haven't got the if statement. We've switched it around, so the if statement is ahead of the for car in cars because we have the else in there. Let's see. Let's change it up a little bit so it will be different from the last example that we had. So if we do O, okay, let's comment that. We can see it's slightly different there, but let's just comment that out. Still got it there for reference. So anything that's got an O in it is just printed the car, and anything that's otherwise it's got A in front of it. So there you go, you can see that. Now if we were to look at cars there, it's just returned none because it's not doing anything, it's just printing. What I was talking about earlier, where they've had the else statement. So if we were to put else and get rid of this print here and just put A plus car, okay, and around that, you see we've got the A Tesla, none, A Rivian, A Grenadier, because it's doing nothing because we're just printing it, and then we're getting that. So the reason I'm talking about this is oftentimes when you're writing your code, you might decide that I'll throw a print in there when I'm doing this string comprehension, this list comprehension, and unwittingly you're adding in extra elements into your list, and then when maybe you do something later with the list length and you wonder what's going on here because the list length is not the same as what I'm expecting, or you're getting a funny error that you're not expecting, it's because you got these nuns in there. So that's just an important thing to remember, that list comprehension, it always returns something, whether it be a none or another element or whatever you're going to do to that element, how you're going to transform it or change it back into the variable that you're passing here as the list name. So that's really important to remember. Okay, some of you may think that's all well and great. Yeah, the list comprehension looks good in the code, but is it any faster? What's faster? Is it faster to do a for loop, or is it faster to do a list comprehension? Well, let's take a look at that. Okay, so some of you may be wondering, is there any kind of time benefit for using a list comprehension over a for loop? Well, I've written out some code here so you can we can see that being tested. The first thing I've had to do is, because I'm using timeit, is wrap it in a function here. And you can see by sort of putting it into the function, I've actually it's become a lot more bulky in the code because of than what I've done down here with this this function, which is where we've got the list comprehension. So that's one thing to bear in mind. But let's run it anyway. You can see the timeit function. All you do for timeit is just import timeit, and then you can do %timeit in front of any function, and it will run it a number of times. And then it will give you this here. So this is taking 1.1 microseconds plus or minus 12.8 nanoseconds per loop. And then this one here is taking 925 nanoseconds plus or minus 11.2 nanoseconds per loop. And it's done, as you can see there, 1 million loops each. So yes, the list comprehension is faster. Now, you may think that's not much time. So we've got another example here. This time we're going to up it from just 1 million to 10 million, 100 million loops. And you can see the differences in the times here. So when we've been doing a for loop, it's got taken 16.7 times to do that 100 million times, whereas this is taken 10 seconds. So if you're working with big data sets, you can see that this is going to make a big difference, particularly if you're doing things like recursion, where you're going down deep into trees of dictionaries. Then using list comprehension is going to be much more beneficial to you, save time than doing for loops. Okay, so that was a introduction to list comprehensions and comparing them to for loops. There's many more things that you can do with list comprehensions, but what I wanted to do in this video was just spend some time looking at fundamentally how they're constructed and some of the basics of how they change around depending on what you're doing, specifically with the if-else statement thrown in there. Probably a lot of the time that's how you're going to use them, that's how they're going to be constructed. I'm going to do another video where we look at doing some more interesting things with them, passing functions in there, and also how you can do set comprehensions, and in addition how you can do dictionary comprehensions as well. So one to look out for. Hope you really enjoyed the video. Hope you like the way that these work. Sorry my keyboard's so noisy. I'll try and get a quieter one for next time. If you do like it, please do like and subscribe. Thank you.